Okay, so we're looking for two integers that have the following relationship. So 14 more than twice the first integer. So what that means is if our first integer, we'll just call them x and y for our integers. Twice the first plus 14. So 14 more than twice the first number gives the second integer. So the result of this is y, our second number. Okay, for the next equation, the second integer is increased by 1, and it gives us the square of the first integer. So our second integer, y, is increased by 1, and it gives us the square of the first integer. Okay, so when we isolate one of our variables here, I've already got y isolated, so I can substitute this whole thing in for my y value here. And we end up with 2x plus 14 plus 1 equals x squared. So I'm going to end up with a quadratic because I got x and x squared, so I've got to move everything to one side and set it equal to 0. So 0 equals x squared minus 2x minus 15. So when I collect my like terms and move everything over, this is the equation I get. First, check to see if you can factor. So we don't have a GCF, but we can factor by inspection. So two numbers that multiply to give negative 15, add to give negative 2, gives me x minus 5 and x plus 3. So I get x equals 5 and x equals negative 3. The question says it had to be two integers. These are both integers, so far either solution can work. Okay, then we solve for our y value. So go back to your original equation and substitute in 5 and negative 3 for x. So I get 14 plus 2 times 5 gives me y. So in this case, y equals 14 plus 10 gives me 24. Okay, the second value is 2 times negative 3 equals y. So I get y equals 14 minus 6 gives me positive 8. So my two solutions are 5, 24, or negative 3 and 8. Since they both have integers, there's no decimals here, both solutions work.